Hello guys, in this video we are going to discuss the solution of the problem linked list that is sorted alternatingly. So let us look at the problem statement. The problem statement says that you are given a linked list of size n. The list is in alternating descending and ascending orders. Sort the given list in a non-decreasing order. So essentially we need to sort it in an increasing order. So let us try to understand the problem statement with the help of an example. So let's take the first example. So this is the list which is given to us, and if you see, the elements of the list is sorted alternatingly. So what does it mean? If you see these alternate elements, so this element which is 1, 2 and 3, so this is sorted in ascending order, and the other pair of elements if you see, which are these are sorted in descending order. So given these two lists, what we need to do is we need to sort the linked list in an ascending order. So the output after sorting this linked list will be 1, 2, 3 and then 7, 8 and 9. So that's about the problem statement, folks. So let us discuss the optimal solution for this problem. And let's take the same example which we have, which is the linked list contains these elements. So this is the linked list which we have. Now we can divide this linked list into two parts. So this is my linked list 1, which is in ascending order, and these contains elements which are 1, 2 and 3. Another linked list which we have is in descending order, and the elements contain 9, 8 and 7. So the idea behind the optimal solution is, given the linked list, we are going to break this linked list into two sub-linked list. So this will be my first sub-linked list and this is my second sub-linked list. And as we know that this second sub-linked list will be in descending order. So what are we going to do with descending order linked list? Well, we are simply going to go ahead and reverse this linked list. So after reversing the linked list, the L2 linked list will look something like 7, 8 and 9. So after this operation, now we will have two linked lists, which is linked list L2 and the other linked list which is L1, which is equals to 1, 2 and 3. Once we have these L1 and L2 linked list, what we need to do is we simply go ahead and we will merge these two linked lists. The merge will return the head of this linked list, and the merge operation we will do, we will ensure that the linked lists are being merged in an ascending order, and towards the end we are going to return the head of the linked list. So that's the general idea behind the solution, folks. Now let us go ahead and write an algorithm for this. So we would like to sort the linked list H1 which is given to us. First step which we want to do is, so now we would like to break the or split the linked list into two parts. So let us split it. Given H1, we are going to split the linked list into two parts, which is L1 and L2. Once we have split the H1 linked list into two parts, what we need to do is we need to reverse the second linked list. Once we have reversed the second linked list, what we are going to do is we are going to simply go ahead and merge these two linked lists into one linked list such that they are in ascending order. And the head of this linked list is something which the merge function will return, and towards the end we are going to return head. So that's the algorithm for the problem, folks. Now let us go ahead and discuss in details about these three algorithms. So let us take the first function, which is the split function. So in order to understand the general idea of the split function, let us take an example. So let us say this is the linked list which is given to us. So what we are going to do is we are going to iterate on the linked list, and we are going to go ahead and have a variable. So we will have a variable which is count, and initially the value is 1, and we are going to increase this count variable by 1 as and when we iterate on the elements of the linked list. Now what that simply means is this is my node 1, this is my node 2, this is my node 3, 4, 5 and 6. So these are the value of the count variables for the respective nodes, and what we are going to do is the odd number nodes is something which will get into one linked list, and let us say the odd number nodes, we are going to keep it in a linked list and we are going to name it as L1. Whereas the even number nodes, which are these 2, 4 and 6, this is something which we are going to keep it in a different linked list, and this linked list will be L2. Let us call this linked list as L2. Now let us see how we are going to do it. So once we are at a particular node, and let us say we are at ith node, so what we are going to decide is whether the ith node belongs to L1 or L2. And this is something which we are going to find out using the count variable. If it is an odd numbered node, then that belongs to L1. If it is an even numbered node, then that belongs to L2. So that information we are clear, and how we are going to deduce it. Now if a particular node, let us say, belongs to L1, then we are going to go ahead and add that value in L1 linked list. If it belongs to L2, then we are going to go ahead and add that node in L2 linked list. So let us see how we can do it. Well, the logic is rather simple. What we are going to do is we are going to have a variable which is ptr, and we are going to set it to h1, which is the head of the linked list, and we will have two more variables, which is L1 and L2, and initially the value of these two variables is none. And then we will have a count variable which essentially dictates whether it's an odd number node or an even number node, and we are going to set the initial value as 1. Now we are going to iterate while ptr is not equals to none. So the first thing which we are going to do is we are going to store the next of the ptr into a variable which is ptr of next, and we will understand it in a bit why this variable, why we need to keep this in a separate variable. Now we are going to check whether the ptr is an even numbered node or an odd numbered node. So let us say that this is an even numbered node. If this is an even number node, then it has to go into L2. And now let us go ahead and write a logic to add nodes into L2. So now if L2 is equals to none, which means there isn't any element and this is the first node which needs to be inserted into L2, then we are going to say that L2 is equals to x is equals to ptr, which is the first node. Otherwise, the x simply is a variable which points to the last element of the list L2. So that is why we are keeping it over here. Now since x is the last element, then the last element x dot next will be equals to ptr. The node has to be inserted towards the end. So that is what I am doing. X dot next is equals to ptr, and let us now update our x. So x becomes equals to ptr. Remember, x points to the last node of the linked list. Similarly, a similar logic we are going to write for the odd numbered node. If it is not equals to 0, count mod 2 is not equals to 0, then that node has to be inserted into linked list L1, and the logic remains the same. So if it is an empty linked list, then L1 equals to y is equals to ptr. Otherwise, it is a node which needs to be inserted towards the last. So y here is towards the last node of linked list L1. So y dot next will be equals to ptr, and then y equals to ptr. So far we have inserted L1. So far we have inserted a node in either L1 or L2. Once we have done this, what we need to do is we need to break the ptr pointer. So ptr dot next equals to none. Since we are breaking this ptr dot next equals to none, and that is the reason why I have initially stored this next into a variable which is next. The next of ptr I have stored into a variable which is next, because here I am breaking it the next pointer, and I would like to go to the next point in order to iterate on the elements of the linked list. So because of which ptr is equals to next. And let's not forget about increasing the count variable. So count will be equals to 1. So that's the logic to split the h1 into two linked list, which is L1 and L2. So folks, if there is a confusion on why this particular step has to be there, so let us try to understand this with the help of an example. So let us say the linked list which is given to us is this, and let us go ahead and use the logic we have understood in order to break it. So what will happen is 1 is there in the linked list L1, and L2 second linked list will be there, which is 9, and then the one next pointer will get changed, and this will be 2. Similarly, 9 pointer will point to 8, 2 will point to 3, and 8 will point to 7. So if we have not broken the next pointer, then what will happen is that this 3 will points to 7, right? And that is the reason why we need to break it. So I hope that that answers the confusion which we had. And now let us move forward. So far we have discussed about how we are going to break the linked list into two parts, L1 and L2. Once we have broken it, now we know that we would like to go ahead and reverse this second linked list. So let us see how we would be able to reverse a linked list. So in order to reverse a linked list, what we need to do is we just need to flip the next pointer. So let's go ahead and see how we can go ahead and flip the next pointer. So what we are going to do is we are going to have a variable which is equals to ptr, and we are going to set it to L2. Then we will have another variable with us which is equals to previous, and initially it is pointing to none. Now we are going to iterate on the linked list. So while ptr. So what does this if previous mean? Well, what it means is that given a node ptr, do we know the previous element of ptr or not? If you know the previous element of ptr, then if previous will be set to true. Now if we know the previous element of ptr, then what we have to do is we need to flip the pointers. So let us go ahead and flip the pointer of ptr. So ptr of next will be equals to previous, right? So that's how we go ahead and flip it. Otherwise, if this is the first node we are visiting, that is how the previous will be equals to none. In such cases, what we are going to say is now the previous is equals to ptr, previous dot next will be equals to none. So let us say this is the linked list which we have. So we are at this element. So we are at this node. What right now the next of this node points to 8, whereas in the reversed linked list this 9 should not point to anything. So that is what we are doing it over here. So previous dot next is equals to none. Once we have done it, now let's go ahead and update our previous and ptr. So previous will be equals to ptr, and let's move forward. So ptr will be equals to next. So here again what we are going to do is we will have a variable next which will store the next of current pointer. So I think I missed that part, but folks, over here we can have our next which is equals to previous dot, sorry, not previous, ptr dot next. And then towards the end what we need to return, well, the head will be pointed by previous. So what we are going to do is we are going to return previous. And that is how you can go ahead and reverse a linked list. So we saw how we will be able to split the linked list, and we saw how we would be able to reverse the second linked list. Now after reversal, the linked list will contain, so L1 linked list which is already in ascending order will contain something like this, and the L2 linked list will contain something like 4, 5 and 6. Now we would like to merge these two linked lists. So now let's go ahead and discuss the logic for merge. So remember, the only thing which we need to worry about is while merging, we need to merge it in an ascending order. So let us see how we can do that. So what we are going to do is we will have a variable which is head, and that is equals to none. Initially, it is not pointing to anything. Now what we are going to check is while we are going to iterate on L1 and L2. Now we are going to check which of these two node value is lesser. So if L1.data is less than L2.data, then L1 node is lesser. So in which case what I'm going to do is I'm going to store the node into L1 and I'm going to move the L1 pointer. Similarly, if L2 pointer is lesser, then L2 pointer data will be, or L2 pointer node will be in my variable node, and L2 is something I am going to move to the next element. So now the node has to be inserted into the merged linked list. So now let's go ahead and do it. So in order to do that, we are going to say that if head is equals to none, which simply means it's the first element, then in such case what we are going to do is we are going to say head is equals to x is equals to node. Otherwise x, since x points to the last element of the linked list, so x dot next is equals to node, and let's move x to the last node, so x is equals to node, and that is how we will be able to merge it. Now after merging, it might be possible that there exists some data in L1, So if there exists some data in L1, then we just have to simply go ahead and point x.next is equals to L1. Otherwise, it might be possible that there exists some data in L2. Then in such case, what I need to do is x.next will be equals to L2. And then towards the end, I will simply go ahead and return head. So that's the complete logic, folks. So that's about the explanation, folks. Now let's go ahead and see how we have coded this. So I've already coded it, folks. Now let me just walk over my code. So here I would like to sort the linked list. So L1 and L2 are two linked lists which we have, and PTR equals to H1 and count equals to 1. Now if it is an even number nodes, I'm putting that data in L2. If it is an odd number node, I'm putting that data into L1. Once I have that, then I am reversing the L2, and then I am simply merging L1 and L2. Now let us look at reverse and merge function. So this is my reverse function, which the logic is the same which we have discussed over here. And this is the merge function which we have. Same here, folks, the logic is the same. So that's about the code, folks. Now let us go ahead and submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.